Welcome to a video on quadratic functions. In this video, we're going to learn about the vertex and the axis of symmetry. Let's get started. We'll start by looking at the vertex of a quadratic function in standard form, which is written as f of x equals ax squared plus bx plus c. The vertex is either the lowest or the highest point on the graph. So if this first parabola opens upward, the vertex is the lowest point on the graph. The second parabola opens downward, the vertex is the highest point on the graph. To find the x-coordinate of the vertex, calculate negative b over 2a. To find the y-coordinate of the vertex, evaluate the function at negative b over 2a. This means that we really want to evaluate the function at the x-coordinate of the vertex. The axis of symmetry for a quadratic function is a vertical line that passes through the vertex, cutting the parabola in half. This parabola here has a vertex at 3, 2, and the axis of symmetry is the equation x equals 3. It's an imaginary line that goes directly through the vertex, cutting the parabola into two symmetric pieces. That means that if you look at points on the opposite sides of the graph, they will be equidistant to the axis of symmetry. The equation of the axis of symmetry is x equals negative b over 2a. Hopefully that looks familiar because that is exactly the same as the x-coordinate of the vertex, and that's because the axis of symmetry is the line that goes directly through the vertex. Let's look at a few examples. For our first function, f of x equals x squared minus 2x plus 3, we need to determine the coordinates of the vertex, identify the equation of the axis of symmetry, and then we'll verify our answers by graphing the function using Desmos. To determine the coordinates of the vertex, we need to start by identifying the coefficients a, b, and c. A is the coefficient of x squared, so in this case, a will be equal to 1. B is the coefficient of the x term, so in this case, b will be equal to negative 2. And c is the constant term on the end, so for this function, c is 3. Now let's determine the coordinates of the vertex. To start, we want to find x, which is equal to negative b over 2a. This means we're going to take negative 2, which is b, divided by 2 times 1, which is a. Negative 2 will give us positive 2 on top, and 2 times 1 in the denominator will give us 2. So 2 divided by 2 will just be equal to 1. So the x-coordinate of our vertex is 1. To find the y-coordinate, we want to find f of negative b over 2a, which really means we just need to take 1, which was our x-coordinate, and plug it into the function. Let's find f of 1 by plugging 1 in for x, so we'll have 1 squared minus 2 times 1 plus 3. That equals 2. So the vertex of this first parabola will be the point 1, 2. The equation for the axis of symmetry is x equals negative b over 2a, which is really just the x-coordinate of the vertex. So for this problem, the axis of symmetry will be x is equal to 1. Now let's verify our answers by going over to Desmos and graphing this function. Go to the website desmos.com, which is also linked in the description of this video. Click on the button toward the middle of the screen that says Graphing Calculator, or from the Math Tools menu, select Graphing Calculator. When the Graphing Calculator first opens, you'll be looking at a blank graph. Go over to the cell on the left-hand side and enter the function. You can use the Desmos keypad at the bottom left of the screen to enter your function. Or if you're working on a computer, you can simply use your keyboard. I've already entered our first function into the first cell. Let's verify that the vertex of this parabola is 1, 2. To do this, go over to your graph and click on the coordinates of the vertex, which in this case is the lowest point. In this case, the coordinates are 1, 2. So the calculations of our vertex are correct. To verify the axis of symmetry is x equals 1, just simply type x equals 1 into the second cell on the left-hand side. Press and hold on the graph settings to the left and change it to a dashed line. I usually change it to a dashed line since technically the axis of symmetry is not part of the function. we see that x equals 1 is a vertical line through the vertex 1, 2, and that it does cut our parabola into two symmetric pieces. Now let's take a look at example 2. For our second example, we'll use the function f of x equals negative 4x squared plus 2. Let's start by determining the coefficients a, b, and c. A is the coefficient of x squared, so in this case, a is equal to negative 4. B is the coefficient of the x term. This function does not have an x term. That tells us that b equals 0. C is the constant term, which in this case, c will be 2. Now let's use a, b, and c to determine the coordinates of the vertex. To find the x-coordinate of the vertex, find negative b over 2a. This means that we need to find negative 0, which is b, divided by 2 times negative 4, which is a. This is just 0. Now let's find the y-coordinate of the vertex by finding f of negative b over 2a, which really just means take the value we found for x, 0, and plug that into the function. So we need to find f of 0. That means we need to take negative 4 times 0 squared plus 2, which will just be 2. The vertex of this second parabola should be at 0, 2. The equation for the axis of symmetry is x equals negative b over 2a, which is the same as the x-coordinate of our vertex. So the axis of symmetry for this second parabola will be x equals 0. Now let's graph the function to verify our answers using Desmos. Go back to Desmos and enter your new function into the cell on the left-hand side. As you can see, I've already entered f of x equals negative 4x squared plus 2 into the first cell. Let's find the coordinates of this parabola by clicking on the coordinates. The coordinates of the vertex are 0, 2, which verifies that our calculations earlier were correct. Now let's verify that the axis of symmetry is the line x equals 0. Go over to the left-hand side and enter the function x equals 0. I usually like to change the color and make sure I change it to a dashed line. It may be hard to see the line x equals 0 because that also corresponds to the y-axis. So I'm going to go back to the graph settings and make this a little bit thicker. Instead of looking at a 2.5 thick line, I might change that to 6 points. Now I can see my axis of symmetry is the vertical line x equals 0. It does cut this parabola into two equal pieces, and it passes through our vertex. That's it for this video. Thanks for watching.